Correct. One announcement. Jeff wrote a note. Open lab is on June 26th. It's 8:30 to 6:30. That's a little different from his usual time of 11 to 9. So on the 26th, it's 8:30 to 6:30. The 26th. I think that's next week.
Yeah. For the lab.
So make a note because I'm going to erase it. On the 26th, open lab is 8:30 to 6:30. 8:30 a.m. to 6:30 p.m. on the 26th. All right. So what I'm going to do is lecture on the female repro physiology, and I'll lecture on the male repro physiology. And this is an overview. We've been talking about all of these things, but this kind of puts it all together. And if you look from top to bottom, on the bottom they have days of the month. 28 days, 1 to 28, for a typical cycle for a sexually mature female. At the top of the figure, I put this in, gonadotropin releasing hormone, because they control the release of FSH-LH. Okay, and we'll see how those drive the ovarian cycle, and how those structures in the ovary secrete estrogen and progesterone, and how those structures target the endometrium. And so that's why I kind of put 3 columns on the board. Hypothalamus, because that's where you get gonadotropin releasing hormone. I put ovary in the middle. And we'll kind of see that it's good to have ovary in the middle, because it kind of feeds back on the hypothalamus and it kind of targets the uterus, so, or endometrium. Really, it's the endometrium. And really, it's stratum functionalis. Just to be specific, it says all that in the slide. But anyways, when you teach a cycle, you can start anywhere, because you'll end up where you started. And today, well, I usually start at the beginning of, or excuse me, at the end of the previous cycle, day 28, when, okay, no pregnancy occurs, you have menses. Now that usually is initiated by drops in the sex hormones, estrogen and progesterone. If you weren't pregnant, those sex hormones drop. You have low levels of estrogen and progesterone, because those hormones are what maintain the endometrium. So if those hormone levels are low, what happens is the spiral arteries that we talked about, they spasm, and that causes the tissue to die and slough off. Spiral AA arteries spasm. That kind of initiates menses. So menses is basically days 28 to around day 5-ish, okay, or day 4-ish. It's about 5 days total. So if you want to go day 28, it's light blue, and they go all the way to day 5 of the current cycle. That's kind of how they target it, roughly those days. And so menses occurs, that you slough off the endometrium. That's what's happening. Discharge, slough off endometrium. You weren't pregnant the previous cycle, and now you get into the next cycle. So what happens is, if you have low estrogen and progesterone, those actually were an inhibition on the hypothalamus. So those low sex hormone levels actually remove inhibition on GnRH. So I'll go over here. Low estrogen, progesterone, remove inhibition on gonadotropin releasing hormone. So what you're going to see is you have the book talks about like they're released in pulses. It's not a steady flow. It's pulsating. So you increase gonadotropin releasing hormone pulses. Starting on days 1 to 5 and into 6 to. Well, basically starting on the next cycle here. So let me point out what I'm talking about here. So when I say you increase GnRH, I'm looking here at the beginning of the new cycle, starting at day 1. You start to have this subtle increase. Okay, that's what I'm talking about. So when that happens, you see an increase in FSH. Now LH is important too, but I'm going to focus on FSH in these in the first part of the cycle here. So you get increase in GnRH. So then in the pituitary, I should probably add ANT-PIT to this, because as you know, GnRH targets the ANT-PIT, and you'll get secretion of FSH, LH. I'm just going to put FSH. You get increased levels of it. And the FSH, it targets follicles in the ovary. So this will take us into the follicle phase of the ovarian cycle. Typically, the follicle phase is something like days 6 to 13. On the figure, they color-coded not that light blue, but the darker blue. Pre-ovulation. Okay. Now, in the follicle phase, as we've studied, you have primordial follicles, which are immature. Now, we've in a typical cycle, this one, we've selected a cohort of 20 to develop, right? I've been saying that all along here. Primordial follicles, select 20 to mature. Really, it's the ones with the FSH receptors present that are going to mature. That's really what's going on. So FSH, it's targeting the primordial follicles, and they'll progress through their stages, primary, secondary. Now, when you finally get to the secondary phase, these 20 of them, right? They're basically developing those mature structures that I talked about last time. They have theca, they have granulosa cells. I'll say it again, I said it before. List theca as a structure under the secondary follicle. Okay, I'll put follicle, because I also talked about primary oocytes and secondary oocytes, but I'm talking about the follicular development. Now, the secondary follicle has the theca that secretes the androstenedione. What I had said in a previous lecture is that androgen is transferred to granulosa cells. So I'll put an arrow, I'll say transferred to granulosa cells. And under FSH influence, aromatase will convert the androstenedione to estrone. So I'll put an arrow from FSH to here, because androstenedione is converted to, on the bottom of the board I'm writing estrone, which is one of the chief estrogens. Okay, so that's due to aromatase. So I'm going to write aromatase on the side, because it's the enzyme that is really facilitating that conversion. It's not FSH, but FSH makes the granulosa cells do it. So in my arrows, let me explain it. FSH is the key. It's targeting the secondary follicle. But what's happening is the androstenedione, which is transferred to granulosa cells, the aromatase in the granulosa cells works because of FSH, and you finally get your estrone secretion. So that's really the key physiology here. And I always have students write about this on the exam. And the hormonal stuff is really what I look for, okay? Because I think that the quote-unquote A-essay, students understand how hormones drive everything. I would say the B essay is students are very good at memorizing the steps, but you omit how hormones cause everything, and you lose points. So it's really all about understanding how hormones drive everything, and everything kind of falls into place. So finally, we have our first sex hormone. We have estrone, or estrogen. And so let's kind of look at where we are in the figure. We're in the follicle phase. We're in this dark blue part. And estrogen is the key here. You see a rise in estrogen right there. And it's supposed to correlate with the developing follicles. There's a secondary follicle right there. That correlates with this first increase in estrogen. So that does a couple of things. That estrogen is going to negatively feed back on the hypothalamus and turn off FSH. So I'm going to draw an arrow from estrone going back to FSH, inhibition. I'm going to put a negative sign for inhibition. I'll just write inhibition. Inhibition. Basically, you're going to turn, at this point, turn off FSH. Turn off FSH. It's negative feedback, okay? Feedback inhibition. If you want to call it negative feedback, negative, because that's really what's going on, do that. I know what that means. Turn off the original stimulus. That's one thing. And what's the reason for that? Okay, first of all, what's the reason? First of all, can you see it on the figure? Look at FSH. Can you see the thing go down? It's right here. It's elevated and then it goes down. So it's like what the body is doing. It's saying, we have our 20. We're developing them. We don't want to develop 200. We want to develop 20. So turn it off. We have our 20 to develop for this 28-day cycle. Okay? So that inhibition is very important. And as I grade the essay, I count the feedbacks. There's like 3 that I look for, and that's one of them. Okay? Now, estrone also, its true target is the endometrium. So I'm going to draw an arrow here that you're going to begin to rebuild the endometrium, and we call that the proliferative phase. So I'm going to have to erase some of this here.
What is estrone pointing to?
What's that?
What is estrone pointing to? Is it pointing to endometrium or the next stage that you're going to write down?
Oh, yeah. Let's do this. Let's make a point up here so I have more room to write. It's going to target endometrium. And it's going to cause the proliferative phase. Yes, question?
Can you say briefly how FSH has to do with the granulosa cells? Is it activating those to make androgens?
My understanding is it influences the granulosa cells through aromatase. Aromatase will convert androstenedione to estrone. And this all happens in the granulosa cells.
So FSH's target, or I guess its influence is to make.
The granulosa cells.
What makes the granulosa cells?
It doesn't make them, it makes the granulosa cells have active aromatase. Yeah. I think you could say it makes them because they do proliferate. I think that is a correct statement. I was just trying to emphasize aromatase activity. But yeah, you could say that too as well. All right, any other questions on the whole, this part? That part's important. You have to know how females secrete estrogen. There's a lot of females in the room, and that's essential to know. How does the ovary secrete estrogen? This is basically it. There's a lot of stuff going on. Okay, well, anyways, I was saying estrone targets endometrium. It causes the proliferative phase. Cause it. The key word is cause. Hormones cause things to happen. This is the essential physiology here. And so let's describe the details I expect to see. You can kind of see what you're doing. You're re-thickening the endometrium, getting ready for the next pregnancy. But this is pre-ovulation, so things have to rebuild, re-proliferate. So let's just say rebuild endometrium. In what way? You're going to increase those glycogen glands. You're going to increase the spiral arteries. You need the blood supply for baby. You're going to kind of get ready for post-ovulation. Now, progesterone is the key there in post-ovulation. So during this time, pre-ovulation, during the follicular phase in the ovary, you're going to increase progesterone receptors. It's like you're priming for progesterone. You're not increasing progesterone, you're increasing progesterone receptors. And one more detail. If you're going to get pregnant, you need to let sperm in. So during this time, you dissolve the mucus plug at the cervix. Basically, think to yourself, let sperm in. All right, so basically that's what you see there. And you see it on the bottom of the figure. And around days 6 to 13, during the dark blue, you're just rebuilding everything. Okay, so those are the kind of details I think you ought to know. Now the follicles are continuing to get just larger and larger. I want to clear the board. We should completely erase it and start over. Do you have any questions before I erase? You can see where we are. And you can see when I'll be done. I'll have to get back to where I started. Okay.
Can you mention the other feedbacks? You said there were 3 of them?
Yeah, this is the first one.
Oh.
The other 2 are coming.
Oh, great.
All right, so where we left off was we get this increase in estrogen, had negative feedback. But now the Graafian follicle is formed. Of the 20 that reached secondary, one follicle achieved dominance in the follicle phase. That's the Graafian follicle. Usually it's the one that presented the most FSH receptors, has the highest aromatase activity, that kind of thing. So one achieves dominance, it's going to secrete more estrogen. So I'm just going to put 2 up arrows to emphasize more estrogen. Before you had a subtle rise, now we have a steeper rise, and that is shown on the figure. Still in the follicle phase, dark blue, it's this rise here. First, we had an increase from secondary follicles, and you get to the more mature follicles, you even see even more estrogen. Now, that larger increase in estrogen has a different effect on the hypothalamus. And before I mention that, well, basically, this increase in estrogen, it'll just continue to prolong the proliferative phase. I'll just say proliferative phase continued. But the important negative feedback that's happening, actually, before it was a negative feedback. You had a subtle rise in estrogen, it was a negative feedback. Actually, this larger rise in estrogen has a different effect. It causes a positive feedback. I'll put a plus sign for positive, you know. And what you're going to do is you're going to get this huge spike in the gonadotropins, FSH and LH, and that's shown. However, I'm going to emphasize LH. Okay. This positive feedback will cause the LH surge. Luteinizing hormone, it surges. Exclamation point. And you can see that large spike in LH just prior to day 14. And well, I'm referring to this rise in LH. That's huge. Because we have our Graafian follicle, but what LH will do, it will target the ovary. It's going to target that Graafian follicle, the one that achieved dominance. And it'll trigger ovulation. The LH surge triggers ovulation. The follicle wall weakens, the Graafian follicle, it ruptures. And if you remember our meiosis, at this point in the Graafian follicle, it's like you have that secondary oocyte, but it's kind of like arrested in metaphase 2, and that's kind of what you ovulate. So, all right, secondary oocyte. It ruptures and I'll say released to oviduct or uterine tube. Okay, so that's important, that rupture, secondary oocyte released. Because now what you've got, kind of put that in parentheses, that ruptured follicle becomes a bleeding body. So that Graafian follicle becomes a bleeding body. In a previous lecture, I call it corpus hemorrhagicum. That's kind of a headache to spell for the students. I'll just put becomes bleeding body. That's what it means. But not for long. LH will transform that bleeding body into yellow body, corpus luteum. That's what I said last time. So I'll draw another arrow from LH. Okay. And I'm going to define it by saying transforms the bleeding body into, running on the bottom of the board, corpus luteum. So this part of, the essay is important. We have the event, the main event, which is, if we haven't figured it out, ovulation. That is the thing. And do we know what day we're on for here? Day 14. 14 days of a 28-day cycle. So right in the middle of the figure, they do show the rupture of the follicle. And it's caused by the LH surge. Okay. So now we go post-ovulation. So before I erase the board, are there any questions? The events leading up to ovulation. Okay, so, well, we're in the luteal phase now. Of the ovary, because you got the corpus luteum, right? LH caused its formation, and LH is a tropic hormone because it controls the release of progesterone. The corpus luteum secretes progesterone. So now we're past day 14. We're into day 15 to 27. The green. Okay? And you can see a rise in progesterone. Okay? So what progesterone does, a couple of things. It targets the uterus. It causes the secretory phase. Key word is causes. As you can see from the figure, on these days, 15 to 27, the endometrium has reached its maximal thickness and becomes a secretory mucosa. Female may notice a clear discharge during this time of the uterine cycle. Now, the uterine cycle is basically ready. Okay. If fertilization occurred, what day of the cycle did it occur on? 14. So it's all right, so if it happened, I got this, I'm ready for implantation, but I want to keep sperm out, so it's you reform the mucus plug at cervix. Keep sperm out. Assuming you let one in. But basically, think of it as a private uterus. Because, you know, if implantation occurs, that's what you want. So reform mucus plug at cervix. That's pretty much the job of progesterone. It has another job. It negatively feeds back on the hypothalamus and pit. I'll draw another arrow here. Negative feedback is the third one. Powerful negative feedback. Negative sign there. What are you turning? You're turning off the LH surge. So it's basically the down part of the spike. It spiked up, and then it went down. Okay, and then you can see that the down of LH, it going down, correlates with the rise in progesterone. Okay, that's what I want you to see. So basically, stop the LH surge. Inhibit LH surge. So basically, dropping LH levels. So there's no gonadotropin. There is no gonadotropin to sustain the corpus luteum, is the point I'm trying to make with that. So it's like the corpus luteum, it's like it committed suicide by design. It secreted the hormone that turned off the gonadotropin that gave it life. Okay. So with no LH, there is no gonadotropin to sustain corpus luteum. Without pregnancy, let's assume there's no pregnancy this time. The corpus luteum has about a 2-week lifespan. Okay. So there's no gonadotropin to sustain corpus luteum. It has about, you know, a 2-week lifespan of secreting progesterone. And they illustrate it quite well. It kind of atrophies and dies at around day 27. It atrophies and becomes corpus albicans at around day 27. So when corpus luteum dies, becomes corpus albicans. Just think of corpus albicans as a white scar. It literally means white body, but it's basically fibrotic scar tissue at this point. And so it's pretty remarkable to follow the life of the one follicle that achieved dominance. You selected 20 to mature, but pretend this is the one. Primordial, primary, secondary, Graafian, ruptured, bleeding body, yellow body, corpus albicans. That's all the same one follicle that went through all of that on the typical cycle. All right, so any questions about this right here, corpus albicans and the luteal phase? Corpus albicans, when you get there, it's the end of it. Okay, well, yeah, go ahead.
Just kind of going back to the beginnings, when application is occurring, when you're explaining them separately, they're actually happening all at the same time.
Yeah.
The whole just the first follicle phase is happening at the same time.
So I'm sure I missed your question.
If application LH, I think these on the graph that they're happening at the same time,
Yeah.
but I guess it looks like separate steps as we're like drawing it out, but they're actually concurrently.
I see what you're saying. They do follow this pattern together, but to simplify, I emphasize one hormone over the other. Okay, so when I talk about the luteal phase, the LH surge, I could have said FSH spikes too, but that's not the real one that's important. I just try to emphasize the one important one. So I guess there's less for you to talk about. I'm trying to make it easier. But you're right. You're right. Things do happen at the same time. Okay, so I'm going to erase all this here. We got corpus albicans. So what we're saying is, this time, no pregnancy. We're continuing on with corpus albicans. Okay, I'm almost done. But we said there was no pregnancy. That's why you had corpus albicans. Remember, what is corpus albicans? It's a dead corpus luteum. So corpus luteum was secreting progesterone. Does corpus albicans? No. Basically, no progesterone, right? So what you see is, I'll say corpus albicans does not secrete progesterone. Let's keep it simple. Does not secrete progesterone. So basically, down arrow, progesterone. Progesterone was the hormone that thickened the endometrium, and estrogen for that matter. But when this endocrine structure dies, the corpus luteum dies from corpus albicans, you can see that that correlates with the drop here. Okay, right around day 27-ish. I'll include estrogen too, although I emphasize progesterone. They're both considered the sex hormones. When those levels drop at around day 27, we're back to where we started from, the spiral artery spasm. And around day 28, menses occurs. And then that's how you know that there was no pregnancy. I mean, even if there was, you lost it. Okay? So of course this unit is reproduction. Let's talk about if there was fertilization on day 14. Okay, so let's kind of like hit the reset button, go back in time to day 14, and reboot, assuming there was pregnancy. This is pretty much easy to understand. The reason you had menses is because there's no sex hormones. Why is there no sex hormones? Because corpus albicans just didn't, it's a dead corpus luteum, and how come it died is because of this. There was no gonadotropin. Okay, so it's all linked together. I'm going to leave that on the board, just erase this. Pregnancy occurs. Fertilization and pregnancy occurs. On day 14, ovulation. Okay? Usually happens on that day after. So going back to day 14, now you're pregnant and usually what happens in around seven days later, day 21-ish, the blastocyst will implant in the endometrium. So fast forward, day 21, implantation of blastocyst. Blastocyst is the technical term for the developing embryo. implantation of the blastocyst, and it's about 7 to 10 days post-fertilization, right? So this is like the first week of pregnancy, okay? Yeah. Now, what I'll teach you more in detail on Friday, I guess, the developing embryo will secrete a gonadotropin. There are cells that support the embryo, and they're called the trophoblast cells. Okay, specific. Let's just get that down. Trophoblast cells of embryo secrete a hormone called HCG. That stands for human chorionic gonadotropin. Chorionic gonadotropin. We'll start to get into the bloodstream at about day 21-ish. Okay, during luteal phase, right? Or during proliferative phase, or no, I'm sorry, during luteal phase, during secretory phase. So we're in day 21. Look where we are. Implantation is occurring when the endometrium is at its thickest, which is by design, right? That's kind of the whole point. That's what it's there for. So we'll go into details of implantation on Friday, looks like. But this HCG, that's kind of like the home pregnancy testing, right? You dip the stick in urine or urinate on it, and it's or whatever. But this is filtered by the kidney because it's in the bloodstream. And if it's in your urine, you're pregnant. Unless it's a false positive, which usually doesn't happen. And the reason why it's such a good test, this particular gonadotropin is only in the bloodstream. It's coming from the baby, right? Because it's a surefire bet. So the reason why you need this needs to sustain the corpus luteum. Because remember, going back to ovary, we're on day 21. It's like, we want this thing to like stick around for a while. Otherwise, you lose the endometrium. So corpus luteum is here before it died. If there was no pregnancy, the gonadotropin that you depended on was this, but it's not there anymore. So this needs another like safety line. So it's like HCG sustains. I'll put sustains corpus luteum. So corpus luteum doesn't die, it lives. And as long as it's alive, it'll keep doing its thing. It'll keep secreting progesterone. Those levels will stay up. Keep on keeping on. Keep secreting progesterone. The progesterone does its thing. It's gonna, I'll draw an arrow over here, kind of, and maintain endometrium. Put it another way, Miss Menses. And again, everyone knows what that means. Maybe you didn't know why it meant that, but now you do. Yeah. So it's like you're going to sustain the implantation and the pregnancy, and the corpus luteum of pregnancy is a few months instead of a couple of weeks until placenta can kick in. So that's it. That's the last permutation there. We're just not going to hit menses. We're just going to like keep on, and then you take the home pregnancy test, and you freak out or get excited, whatever it is. I'm not commenting on society, but just the physiology is usually you go to the doctor. What does the doctor do? They do the same test. And what do they ask you? Maybe some of you know. Well, what was the first day of your last menstrual cycle, right? Because usually that's something that the woman can recall. And then from that day, they calculate your due date, right? Yeah. And how many weeks is it? 40. And why is it 40? Well, the last menses you had, were you pregnant? He asked you when your last period was, but were you pregnant then? No. But you were 2 weeks later, right? That's what they assume. Oh, okay, this was your last one. You probably got pregnant 2 weeks after that. The normal gestation is 38 weeks, so they just add 2 weeks to 40. Okay. Someone have their hand up? Are you stretching?
I'm stretching.
Yeah, question?
Just out of curiosity, so when the period cycle is more than 28 days,
Yeah.
are the stages like more further, like
Yeah, it could be.
longer?
Could be 35, yeah.
Okay.
So yeah, that kind of like 2 weeks is its estimation. You may not hit your due date. You may come early, maybe a little late, right? Because it's not always 28 days. But usually people know. Okay, I'm marking my calendar. My wife. That's the information I like to know. Yeah.
During all of that, none of that is feeding back to that environment
Oh,
Would you be able to do anything?
yeah, you know what? As long as sex hormone levels are high, this is off. Okay? So the only thing that is keeping this going is the HCG. But then when placenta kicks in here, those will secrete a lot of hormones that keep it going. So nothing's coming from here throughout the pregnancy. Yeah?
So with amenorrhea, like none of this process is occurring?
Amenorrhea?
When you don't have periods.
When you have what?
When you don't have periods. So when you don't have periods for a long period of time, you just don't go through any of this.
Are you talking about menopause? Or it could be, there are multiple
Anything,
causes
yeah.
for amenorrhea.
Yeah.
Yes, basically. That's the short answer.
Yeah. Okay.
All right, let's take a break, and when we come back, we'll talk about male repro.